Hi everyone, I am Fan from Monash and I work with Rob and Anastasios on this project, Manifold Learning with Approximate Nearest Neighbors. So the problem of interest is the electricity usage patterns of different households. We have this Irish smart meter data, which is a half-hourly data for 535 days in over 3,000 households. Instead of, if we look at this time series plot, you will notice these two different households are they behave different, but the actually time of week and day of week pattern, time of day and day of week pattern are hidden due to the large volume of the data. So instead of working with observations directly, we work with these empirical probability distributions so that we'll have 336 distributions for each household. That's a lot of distributions to work with, which is why we choose manifold learning to do some dimension reduction. Basically, manifold learning works by preserving the local geometry structure. There are 4 manifold learning methods shown here. So there are 2D embedding plots from these methods, isomap LLE, Laplacian eigenmaps, and Hessian LLE. I have colored the time of day here, and you can notice that similar colors are clustered together, which means the embedding, the 2D embedding can show some time of day patterns. But what if you have 8 million households in Victoria? The computation efficiency matters. Since manifold learning works by preserving local structure, so there are nearest neighbors involved. Therefore, we propose to improve the efficiency by searching for approximate nearest neighbors instead of exact ones. There are 3 ANN methods, KD trees, anomaly, and HNSW here. KD trees, for example, achieved the approximation by introducing the epsilon parameter and increased the searching range. The goal here for this research is to largely decrease the computation time without losing much accuracy, measured in the embedding quality, say trustworthiness. So we are expecting a low computation time in the x-axis and a high trustworthiness on the y-axis, so top and to the left. We can see here anomaly in the red is behaving the best, while KD trees in blue has the highest level of quality measure. So now we can apply this ANN combined with manifold learning into our data set. And in the bottom, you can see we have similar patterns achieved. And if we look at the Hessian LAE, for example, we can highlight those anomalies here in black based on the density. And you can similarly apply this to millions of households and other high-dimensional data as well. So that's all. Thanks for listening. I have the slides also available here. Any questions?